Okay, so construction is the largest industry in the world. It's about a $10 trillion industry worldwide. About 10% of that total spend is wasted due to rework. So what is rework? To illustrate what rework is, I'm going to give you an example of a site that we've actually recently been on. That building is 151 Maiden Lane downtown. When 151 Maiden Lane was going up, it's a concrete building. A hole was supposed to be left on the 5th floor for some HVAC ductwork to go through. Inspector didn't come until the building had topped out. HVAC guys come in. They say they find this hole that's supposed to be left for the duct, and it's 2 feet too low. New York City code requires that you have 7.5 feet of clearance for all your ducts. Now they're only going to have 6 feet. That's a problem. If they had caught that problem as the concrete was being poured, not a big deal. You move the hole. Now that they've topped out 25 stories sitting above this hole, above this floor, that cost them a 6-week delay, and they had to reconfigure their entire HVAC system. That's rework. What we want to do is we want to catch mistakes as they happen. So instead of spiraling into these huge conflicts with your subcontractors down the road, you catch them immediately and fix them immediately. And the way we do that is the following. We use autonomous drones that are capable of navigating indoors by themselves to do laser scans of the building to capture the reality. We then use a nearest neighbor algorithm to compare the scan to what's called the building information model, which is essentially a really high-tech 3D blueprint of a building. And then we deploy our algorithms to do automated deviation detection. So this comparison happens, and we find the places where reality does not match the plans.
So let me take you over the demo.
I think it's a live link.
Yeah, I'm not going to use the live link because I want to reload the page. Oops.
Just escape.
Sorry. Just gonna... Oh, because I'm in the browser.
Correct.
That makes sense. Right. So, so this is our laser scan on top of a sampled version of the building information model. That's the 2 different colors here. And then we have over here on the left, we have the annotations that are algorithm generated that are saying like, hey, this column's out of place, this wall is out of place, and you can click on them, and it'll take you to that point in the model. Oops. I have this mouse for a reason. A little zoomed in. Not all of our points are loading today, but you can see the building. And then you can add a comment and say like, you know, this column needs to move, and you know, have a conversation about the problems that are going on in your model and communicate with your team. And then you can also go in, oops, and see, you know, the different versions of your model in here. So here you can see just the actual 3D plan. So.
All right, Vamsi?
Okay.
Mike?
All right. I guess I'm loud enough for everyone. Yeah. So whenever point cloud comes into place, the contractors or the developers will say, oh, those are a bunch of points. How can I associate points to a model? So the algorithm, our algorithm is smart enough to identify what points do the object belongs to and directly associate the points
Let's go next.
to the objects and detects everything. If your column has moved from one place to the other, if your wall has moved, you can see all those pictures which shows that there is a deviation from what you have planned versus what you have built. So, and then eventually you'll get a fine new Navisworks model outputted from the portal wherein you can collaborate with different teams. You want to, you know, sue the structure guy, go ahead for that. Say that, okay, you built the entire plan wrong, or the contractor, everyone. So you have a Navisworks model, you have a viewer in place, you have a portal which can be collaborated between different teams at one time. And the best part of this is it's real time. You don't need to wait, unload your point cloud to your computer, and then start working on it. It's real time, and you can work on site whenever it's scanning, and then eventually you'll get the results as soon as you want.
So I just want to call out here that this is actually the analysis that we ran here.
Yeah, this is the analysis we ran. We put in put this colored picture in the portal, but eventually you see that the green ones are all good, which means the contractor actually constructed where they should be, but the red ones are not, because they have a lot of changes. And the yellow ones is, we don't know, which means we need more input. Even though it's automated, we want human to take care of few of those changes and tell that, okay, few of these maybe not enough for the algorithm to take care, so the human
Right,
will
so
come ahead and take care of those.
basically due to the limitations of a hackathon, we weren't able to get our full analysis up into our portal. And obviously our neural network is still being trained, so there is still some human input required on the yellow aspects of the model, but you can see where we're headed. And to further highlight that, this is the design we're working toward. Eventually you'll have a model that teams are able to collaborate on. A schedule will be integrated, so we can eventually also track progress. There are applications in mind, for example, construction lenders who need to pay out a draw. And need to base that draw on percentage completion for each subcontractor. If the schedule is integrated, we can actually figure out what percent completion the MEP contractor has completed of his job, and automate the process of lender inspection. And that's what we've done this weekend.
Questions from the judges?
Yeah.